Okay, so we all need a filled in unit circle to help us today, and then our notes. And your graphing calculator. Okay. So just a quick review to get us started. Then we're going to talk about, well, yeah, let's do let's sketch the 30, 60, 90. So that first triangle in the first quadrant there. So let's start. Draw a sketch of that 30-degree angle. Label it 30 here. Okay. Now, on our 30, 60, 90 triangle, we know the lengths of the sides, right? That's our 30-degree angle. That means we have to go, to get to this point on the circle, we have to go to the right, √3/2. And then up 1/2. Then we know our radius is 1. So it's called the unit circle, because the distance to the outside is always 1. Okay, so we're going to do a little review from geometry. We did this a couple weeks ago. We talked about sine, cosine, and tangent, and SOHCAHTOA. So we're going to find the sine of 30, the cosine of 30, and the tangent of 30. Okay, so SOHCAHTOA, I'm going to write that at the top. So we have it, and we know it. SOHCAHTOA. All these trig functions do is compare two sides of a right triangle. Sine compares opposite and hypotenuse. Cosine compares adjacent and hypotenuse. The tangent compares opposite and adjacent. It's just a comparison. So if I want the sine of 30 degrees, I need the opposite and the hypotenuse. So here's 30. The opposite side is 1/2. And the hypotenuse is 1. That just gives us 1/2. The cosine of 30 is adjacent over hypotenuse. So 30 degrees. The adjacent side is the side next to 30, but not the hypotenuse. So √3/2 over the hypotenuse, which is 1. That just reduces to √3/2. Now, so we don't have to set up a right triangle every time when it's an angle that we know on the unit circle. So these are the most common angles that come up. We don't have to do SOHCAHTOA to figure out our answers. The x value of our coordinate point is always going to end up being what cosine is. Bless you. And the y value is always going to end up being what your sine is. So we know our coordinate points. The x value is √3/2. And that's what we got for cosine over here. And for y, the y value is 1/2. And that's what we got for sine over here. Now tangent, opposite over adjacent. If I take the opposite side, which is 1/2, over the adjacent side, which is √3/2. Now if I simplify that, the 2's will cancel. I just get 1/√3. And then I'm going to fix that radical. I'm going to rewrite this as √3/3. So there's also a quick way to get tangent. Tangent is always ends up being what your sine is over what your cosine is. Let's write that down in the corner somewhere. Tangent, we'll call it of x, is equal to sine over cosine. So in this list here, where it says the trig functions, we've got the three that we know. That's them all written out nicely, not abbreviated. So sine is actually spelled S-I-N-E, but we abbreviate it S-I-N. And we know that that's opposite over hypotenuse, or our y value. Cosine, we abbreviate COS. That's adjacent over hypotenuse, and that is our x value. And then tangents, opposite over adjacent. That is also sine over cosine. So those ones you did in geometry. Now, adding on to that, there's three other trig functions that you probably didn't do in geometry. So they're actually the reciprocals of the trig functions right above. So the reciprocal of sine is called cosecant. We abbreviate that CSC. And instead of opposite over hypotenuse, it's hypotenuse over opposite. Cosine's reciprocal is called secant. We abbreviate that SEC. So that is hypotenuse over adjacent. Then we have cotangent. That is the reciprocal of tangent. That is abbreviated COT. That would be adjacent over opposite. We're going to take a little break, not break, but we're going to take a little pause on the notes here. Let's go find our formula sheets. That lovely yellow color. Okay, so let's put in some definitions here in our formula sheets that we have them. So we know sine is opposite over hypotenuse. So sine adjacent over hypotenuse. Tangent opposite over adjacent. We also know that cosine is my x. Sine is my y. We also know that tangent is sine over cosine. I'm gonna write that down too. Okay, so let's do the reciprocal trig functions. Cosecant is the opposite of sine, so hypotenuse over opposite. Secant is the opposite of cosine, hypotenuse over adjacent. And then cotangent goes with tangent, adjacent over opposite. Hello.
What about here?
I don't know. You there if you did. So no. So no. What it look like?
It's just a weird one body.
Yeah. Okay, let's go back to our notes and let's try some practice problems. So let's flip to the back. This is where a unit circle is going to come in handy. So you're going to want that out side by side and your formula sheet. Got a lot of things. We're going to find the six trig functions of pi over 6. So first, think about where pi over 6 is on your unit circle. We already did this one, I guess. Pi over 6, 30 degrees, right? So it's that first one on the right. So we're going to find the six trig function. What I like to do is write them all first, and then I go in and fill out the answers. So I'm going to find the sine of pi over 6, cosine. This is the worst part, writing it down. Let's start with those three, and we'll add the other three in. Let's start with sine. Sine is the y. Now, I could set up a right triangle and solve it, but I don't want to have to do that. That's a lot of work. But I know that whatever I get for that right triangle, it's going to be the same thing as my y value. So if I think about the y value at pi over 6, it's 1/2. Cosine is our x value. So if I think about the x value at pi over 6, I know that's root 3 over 2. And then tangent of pi over 6. I can remember from my formula sheet, you can see it right on there. Look at tangent. Tangent is sine over cosine. So 1/2 over root 3 over 2. The 2's cancel. That's 1 over root 3. That gives me root 3 over 3. Once you have those three, the other three, we're just flipping. But we do have to remember which is which. That's the hard part. So you have your formula sheet to help you. The reciprocal of sine is cosecant, CSC. So if I flip 1/2, we get 2. The reciprocal of cosine is secant, SEC. So if I flip root 3 over 2, that is 2 over root 3. Well, here's kind of a pain. I have a radical in the denominator, so I want to fix it. I'll go through it the long way. I'm going to multiply top and bottom by root 3. That gives me 2 root 3 over 3. And then my last one, the reciprocal of tangent, is cotangent of pi over 6. So I'm going to flip root 3 over 3, so 3 over root 3. Gonna fix this, so I'm gonna multiply by root 3. It gives me 3 root 3 over 3. And then these 3's will cancel, so that's just root 3. So ends up being quite a bit of algebra, or simplifying. Okay, let's try number 2. Number 2, we have 5 pi over 4. So we have our unit circles memorized. Shouldn't have to look at the unit circle. But if you do, it's in front of you. What quadrant is 5 pi over 4 in? The third, yes. Down in the third quadrant. And I know to get there, I have to go left and then down. So I know the coordinates are negative root 2 over 2, negative root 2 over 2. This is why it's helpful to have the unit circle memorized, because you won't be able to use the unit circle on tests. So once you have it memorized, you can pull this up from your memory and be able to solve problems. That's the whole point of us memorizing. Okay, so let's make the list. Let's start with sine, cosine, and tangent. Now you can cheat a little bit. Instead of writing 5 pi over 4 over and over again, they tell us that t is equal to that, so I can just use t instead. Please us from writing. Okay, I'm gonna start with the easy ones. This one's all not too bad. Sine is the y. Well, the y is negative root 2 over 2. Cosine is the x. Also negative root 2 over 2. And then tangent is sine divided by cosine. What happens when I divide these two numbers by each other? I get 1. Now I'm going to do the reciprocals. I just have to remember which one goes together. So sine and cosecant go together. Cosecant. We've got secant. And then cotangent. Okay. I'm going to flip sine here. So that would become negative 2 over root 2. I'm going to fix it. I don't want that radical in the denominator. I'm going to multiply by root 2. Negative 2 root 2 over 2. These 2's cancel, which is negative root 2. These ones are going to come up a lot because they're common angles. So you'll get used to these. You won't have to do all that work. You'll just remember what the reciprocals are. Secant, if I flip this, I'm going to get the same thing, negative root 2. And for cotangent.
Please excuse the interruption. David may come over to the main office for dismissal, please. David may come over to the main office for dismissal. Thank you.
If I flip 1, if I write it as a fraction, is 1 over 1. If I flip it, it's still 1 over 1. Okay, let's try 0. So we know where 0 is. Over on the right, I know the coordinate points of 0 are 1, 0. Okay, so let's make the list. Sine, cosine, and tangent. Okay, sine is the y. So my y value is 0. Cosine is the x. That is 1. And then for tangent, sine over cosine. 0 divided by 1 gives me 0. Now I'm going to do the reciprocals. Cosecant, secant, cotangent. Here's a tricky question. If I write 0 as a fraction, how would I write it? 0 over 1, right? That's how we write everything as a fraction. So I flip 0 over 1, what do we got? 1 over 0. What is 1 over 0 equal to? Not 0. Undefined, yes. Get my posters up here, right? 0 and undefined, those are opposites. Those are reciprocals of each other. 0 on top, that means the answer is 0, it's okay. 0 on the bottom, not okay, that's your undefined. Okay, so secant is going to be the reciprocal of 1, which is still 1. And then cotangent, the reciprocal of 0 is also undefined. That means it doesn't exist. There's no answer. So why that happens again is because remember these trig functions, you're just comparing two sides. If you're comparing a side divided by another side to 0, that's why that ends up being undefined. Okay, let's do one more. Let's get pi. Pi is an easy one. Let's do negative pi over 3. What quadrant is negative pi over 3 in? in the fourth quadrant, right? So if you think about this two ways, it's actually going to be in the same spot as pi over 3, but down in the fourth quadrant. Where does it match up with if you look at your unit circle? What angle? Would it match up with 5 pi over 3? Yeah, so it's going to have the same coordinate points. You're just talking about a location. So it's the same spot. It's in the same spot as 5 pi over 3. So I'm going to use those coordinate points to figure out my ratios. So 5 pi over 3, we go right and then down. So root 3 over 2, negative 1/2 are my coordinates there. Again, have your unit circle memorized. Wait, say that backwards. Oh my gosh, yeah, I was doing 30 degrees, not 60. Oh, yeah, I saw some of your puzzle faces. You're right. I was wrong. I was thinking it was opposite 30. It's opposite 60. Okay. 1/2. Negative root 3 over 2. There we go. That's better. Okay, so I'm going to make my list. Sine. I'm going to use t again, so I don't have to write negative pi over 3 6 times. Cosine. And tangent. Sine is the y. Negative root 3 over 2. Cosine is the x. 1/2. Tangent, we divide sine by cosine. So if I divide this fraction by this fraction, the 2's cancel. I'm just left with negative root 3 over 1. So negative root 3. Now I'm going to do the reciprocal. Cosecant. Secant. And cosine. And I'm on a distracted question over here. Okay, cosecant. I'm going to flip this. Now I already flipped this up in one of the other problems. So if I remember this one, if I flip that, that's negative 2 over root 3. So that would be negative 2 root 3 over 3. If we flip 1/2, we get 2. And then if you look up above, if you remember what we got when we flipped negative root 3, that would be 1 over root 3. Negative root 3 over 3. Go back to what I was thinking about over here. You already do a homework 1 in here? Yes, you did. Okay. No. Right. I get it. I was confusing myself. Okay, we're gonna keep practicing this tomorrow.